Booting intro. Mr. Vaughn's classroom. Math made cheesy? No, math made easy.
Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on the video, I'd like to ask you to please subscribe to the channel, give this video a thumbs up, and engage with a comment below. Our video today is looking at Unit 3 on Similarity. This is Lesson 13, using the Pythagorean Theorem and Similarity. Our learning goal says let's explore right triangles with altitudes drawn to the hypotenuse. We have one learning target in this lesson, and that says I can find similar triangles formed by the altitude to the hypotenuse in a right triangle. With all of this in mind, we do have one glossary term, and that is altitude. An altitude in a triangle is a line segment from a vertex to the opposite side that is perpendicular to that side. If you notice, we're drawing this dashed line out of one of the vertex or corners of the triangle, and we're drawing it in a way that it ends up exactly perpendicular to the line that is across from that vertex. Now that we're done with this introduction, let's go ahead and take a look at those practice problems.
Some people say this is too complicated, but when we invest in our communities and our education, we can solve any problem. Let's start with this one.
Practice problem number 1. In right triangle ABC, altitude CD is drawn to its hypotenuse. Select all triangles which must be similar to triangle ABC. So I'm going to try and diagram this out as much as possible to help you understand what I'm doing here. When they drew this altitude, CD, from the 90-degree angle down to the hypotenuse so that it formed another 90-degree angle, we have essentially created 3 triangles. We have the original big triangle. And this original big triangle is ABC. Now, they've also created this small triangle over on the left. And that is A, D, and C. And then they've created this triangle on the right side. And we can label that with points D, B, and C. So now we've got to figure out the corresponding sides. So this is a 90-degree angle. This is a 90-degree angle. And this is a 90-degree angle. So first, we're going to highlight this short side that touches the 90-degree angle. And so all 3 of these blue sides are going to be corresponding. And now we know that across from the 90-degree angle is your hypotenuse. So we're going to highlight the hypotenuse green in each triangle. So we know that these sides are corresponding. And then that just leaves the long side that touches the 90-degree angle. And we're going to highlight these in yellow, so we know that all of these yellow sides are corresponding. So now we're going to figure out how we'd name these. So remember, the original was named A, B, C. So we start out with A in the original, and that is the corner where blue and green meet. So that's going to be our first letter. The second letter in the original triangle was B, and in the original triangle, that is where green and yellow met. And then in the original triangle, the last letter they used was C. And in the original triangle, that is where yellow and blue met. So, in the original triangle, that was triangle ABC. So we know, obviously, ABC is similar to ABC. Now, in this small triangle over here on the left that was created, our first letter needs to be where blue and green meet. So in this triangle, that is A. The next letter needs to be the corner where green and yellow meet. So that's going to be the letter C. And then our final letter is going to be the corner where yellow and blue meet, which happens down here at D. And so if I look at my choices, B is this small triangle that was created. And then lastly, we've got the bigger of the two new triangles that were created. We're going to start in that corner where blue and green meet. So that corner is C. Then we're going to go to the corner where green and yellow meet. So on this one, that's down here at B. And then the final corner where yellow and blue meet, the 90-degree corner, that's D. So if I look at my choices, CBD is choice F. So the three triangles that must be similar to triangle ABC are triangle ABC, the original, triangle ACD, the small triangle that was created, and triangle CBD, the larger of the two new triangles that were created. The letter order is important because we want to make sure that we're matching up the same letters with the same corners. So in the original ABC, C was my 90-degree angle. It was my last letter. Well, now D was my 90-degree angle in the new triangles. So notice that D is now the last letter. We got to make sure that we have the corresponding sides and the corresponding angles in the same order. I hope the color coding here and drawing the three triangles and all of that helps you understand this better. But if you do still have any questions, please feel free to leave a comment below.
We're going to have so much winning, you'll get tired of winning. You're going to get tired of solving all these fantastic problems.
Practice problem number 2. In right triangle ABC, altitude CD with length h is drawn to its hypotenuse. We also know AD equals 12 and DB equals 3. What is the value of h? So in order to solve this, we're going to look at the two triangles that were created by drawing in the altitude. First, we have the triangle on the left side, the larger triangle. And down here we have 12. And on the end we have h. Now the other triangle that was created was this smaller triangle on the right. And we know that the bottom is 3 and the side here is h. And then we have our 90-degree angles. So we need to make sure we understand which sides are corresponding. Now, from our 90-degree angle, we have a short side and a long side. And so our short sides I'm going to highlight in blue. 3 in the small triangle corresponds with h in the big triangle. And then the long side in the small triangle is h, and the long side in the big triangle is 12. So the sides that are green correspond. Now we can set up a proportion. We have 3 for the short side in the small triangle, and we have h for the long side. Now, if we say that these are corresponding, then the 3 corresponds to the h in the big triangle, and the h in the small triangle corresponds to 12 in the big triangle. So this is how I set up my proportion. Now, what I need to do from here is I need to cross multiply. So I'm going to multiply 3 times 12 equals 36. And then I'm going to cross multiply h times h equals h squared. Now remember, we're trying to solve for h. So the opposite of h squared would be taking the square root. And if I take the square root of one side, I've got to take the square root of both sides. As soon as I do that, the square root and the square cancel each other out. So on the right side, I'm left with h. On the left side, the square root of 36 is 6. So we have found our answer. And if you want to check if that makes sense, then we could say that 3 for the small and 6 for h means the longer side is twice as big as the short side. Well, if we substitute 6 in for h on the larger triangle, then 6 is the small side, 12 is the long side, and we still have that same proportion where the long side is twice as big as the small side. So I hope having these colors in this diagram helps you understand this better. If you do still have any questions, please feel free to leave a comment below.
You kids have it easy. Back in my day, we didn't have calculators. We had to use our noggins.
Practice problem number 3. In triangle ABC, not a right triangle, altitude CD is drawn to side AB. the length of AB is C, which of the following statements must be true? So it's always a good thing to highlight some key information that they give you here. So the first thing that I would highlight is remembering that it specifically states right here, this is not a right triangle, and that's going to make a difference. Then notice it says which of the following statements must be true. Okay? Not could be true, not might be true. Absolutely 100%, you know for a fact, must be true. So now let's go through our answer choices. Choice A says the measure of angle ACB. All right, we know that the angle ACB equals 75 degrees. It says this is the same as measure of angle B. Well, the problem is we don't know. They don't give us the angle measurement here, and there's no other information given that would allow us to find that out. So for A, maybe it's true, but there's not enough information. Okay, that might be true, it might not. We don't know, so therefore we cannot say that it must be true. Option B, B squared equals C squared plus A squared. Well, they told us that the altitude is drawn to side AB. That means C is the hypotenuse. And if C is the hypotenuse, then the Pythagorean theorem is that A squared plus B squared equals C squared. So the problem here is that they put the C squared with the A squared instead of by itself, and they put the B squared by itself when it should be with the A squared. So B is definitely wrong. Option C, triangle ADC is similar to triangle ACB. And this, at first, is probably very tempting for you to say that this is right. Because if I draw my altitude down, then I create these two smaller triangles that I want to say are similar to the original, and we might pair it up and say that these two triangles are similar. But remember what we highlighted at the top. This is not a right triangle. So altitude creating similar triangles only works with right triangles. And this is because you would be drawing from a 90-degree angle to create the two 90-degree angles at the bottom. But here you're drawing from a 75-degree angle and then creating two 90-degree angles, so they're not going to be similar. So that brings us to our last option, Choice D says the area of triangle ABC equals 1/2 H times C. So remember that the area of a triangle equals 1/2 base times height. So in this case, for triangle ABC, that's going to be 1/2 times the base, and the base is C, times the height, and the height is H. So this is true. It doesn't matter if we say 1/2 C times H, or if, like they did, 1/2 H times C, because you can multiply in any order. So D is the statement that must be true. I hope this explanation helps you out. If you do still have any questions, please feel free to leave a comment below. Now, before we end the video, let's go ahead and review the learning target for this lesson. Okay, so looking back, we did have one learning target in this lesson, and that said I can find similar triangles formed by the altitude to the hypotenuse in a right triangle. So the biggest thing is understanding that as long as what you start with is a right triangle, then if you draw a line from the 90-degree angle in that triangle down to the hypotenuse in a way that it makes it perpendicular to the hypotenuse, you will create two new 90-degree angles and two new similar triangles. Then you can use those three triangles to try and answer questions about any missing data that you might have. I hope all the practice problems and my explanations of them have been helpful. If you did find it helpful, I ask you to please give this video a thumbs up. In the bottom left of the screen, you'll see another video of mine that YouTube is recommending for you. In the bottom right of the screen, you'll see a subscribe button to the channel. It would really help out if you subscribe to the channel. Also, I ask you to please engage with a comment below. And if you find my teaching style helpful, in the description below, I will link to my SuperProf and Wyzant tutoring pages. You can schedule some one-on-one tutoring with me if that is something that you would find helpful. As always, I look forward to seeing you in the next lesson.